Good evening, sir.
Hello. Yeah. Good evening. Uh, have you started doing the exercise for this chapter 20?
Sir, I have doubt from previous question.
What are the doubts?
Like in exercise 18, question 6.
Which question is it?
Question number 6.
Tell me the question, which one?
Cos A equal to 0.28.
Find the value of tan A by 2. You have to find tan A by 2 given cos A value. What is the issue? You don't know how to find tan A by 2 from here.
No, I know, like, explain the resulting ambiguity.
How many values of tan A by 2 is possible?
Okay, okay.
Is it only one value possible or there are two values possible?
2.
Why 2? How will you find the value of tan A by 2 first of all?
Like, I will find tan A by, first I will find tan A.
How?
Like, I will write cos A equal to 28 by 100. And then I will simplify it. And
If you find tan A value from there, how will you find tan A by 2?
like I will apply like tan 2a formula. So
Will that have a multiple roots or single value will come?
um, so no multiple roots because quadratic will form.
Why are there multiple answers? That is what you have to explain why there are multiple answers.
Okay.
Tell me why there are multiple answers. Even cos A is equal to this value. Why are there multiple possible answers for tan A by 2? The answer is simple. Cos A 0.28 means A could be in the first quadrant also, and it could also be in the fourth quadrant, right?
Yes, sir.
So there are two values of A possible.
Yes, sir.
At least two. Actually, infinite values are possible, but at least two different values of A angle are possible.
Yes,
Obviously, A by 2 will also have two different values from here, and there can be two different values of tan A by 2.
yes, sir.
Do you understand what is happening?
Yes, sir.
What is the next doubt?
Next out is question 8.
Same exercise.
Yes, sir.
Sin theta plus sin phi is equal to A. Cos theta plus cos phi is equal to B. Find the value of tan theta minus phi by 2. Okay. What have you tried in this question? Did you try anything?
Yes, sir. Like I wrote tan theta by 2 minus tan theta by 2 minus pi by 2. And then I do like tan A minus B.
That's not a proper way to do it because you know the value of tan A by B or tan S by 2. Do you know any of these values?
Oh, sure.
So if you don't know the values, what is the point of expanding it using these? Is there some benefit from that?
No, sir.
Finding this value or this value from these relations is going to be easy or hard?
Um,
It is going to be super annoying to try to find out tan theta by 2 from here.
yes, sir.
You have to do something else. You have to make this somehow in a different way, not by this method.
Yes,
What else can you say about this equation? What can you figure out from this equation? Sine theta plus sine phi is equal to A. What can you write it in any different way?
like sin c plus c for.
It is clearly this. Is it equal to this?
Yes, sir.
Can you write cos theta plus cos phi also in that way?
Yeah, yes, sir. Oh, easy.
You realize that you just have to divide now.
Yes, sir.
You don't have to just divide. I think if you divide, you'll get tan of theta plus phi by 2. Right?
Yes,
Can't divide because dividing will do what? It will cancel the theta minus phi by 2.
oh, yes, sir.
But at least we are on the right track. You can do, you can see that cos theta minus phi by 2 is common. Both the expressions have it. So what we can do is, you can do square of this a square is 4 sine square theta plus phi by 2 cos square theta minus phi by 2, and b square is what? 4 cos square theta plus phi by 2 and cos square theta minus phi by 2, right?
Yes, sir.
What is a square plus b square? We can take 4 cos square thing common and it will be sine square plus cos square, so that will be 1, right?
Yes, sir.
Now we are getting the value of this. To understand what is happening,
Yes, sir.
are you just saying yes or are you understanding what I have done?
Yes, I understood.
If you know the cos square theta minus phi by 2 value, that is coming out to be a square plus b square by 4. It is easy to find sine square theta minus phi by 2, which will be 1 minus a square plus b square by 4. If you know this value and this value, tan square theta minus phi by 2 is basically the quotient of this and this, right?
Yes, sir.
4 minus a square minus b square by a square plus b square. And root of that is your answer.
Yes,
Is it clear what is happening?
yes, sir. Understood.
What is the next doubt?
Now, next out is chapter 9 on articles, page number 106.
What is the doubt? Tell me.
Like there is a, like if the angles be all equal and there be n of them and h equal to theta, then s1 equal to n tan theta is just equal to n c2 tan square theta. How does it come?
He's just Trying to derive the formula. You don't have to worry about this formula, right?
Okay.
He's trying to derive the formula for tan of n different angles.
Yes.
Tan of a1 plus a2 plus an. How did we learn how to do tan a plus b plus c? What are you supposed to do to find that?
Like first group A plus B, and then A plus B will identify as one, and then plus C.
So if you extend that process, you can find tan of a plus b plus c plus d also. And similarly, you can find for five angles also. If you keep doing the same process again and again, finally, I want the expression for this. You understand what I'm saying, right?
Yes.
By the same grouping method, you can find the expression for this. What he is telling you is how he got the formula.
Okay.
He's defining the terms S1, S2, S3, and he's telling you the final formula in that case. S1 is the sum of the tangents of the separate angles. S2 is the sum of the tangents taken two at a time. If you take two of the angles at a time, how many pairs will come?
Like two angles in, well, two tangent in the multiple form.
If there are five angles, you want to take two of them at a time. How many ways can you select two of them at a time?
Like 5C2.
That is what he is telling you. If there are n angles, it is nc2 pairs will come. You know what nc2 means?
Yes, sir. Like n factorial by n minus 2 factorial into 2 factorial.
So that all of that article is just trying to explain how the formula comes. He's trying to explain the formula. The formula is S1 minus S3 plus S5, S1 minus S3 plus S5 minus S7 alternating, and denominator is 1 minus S2 plus S4 minus S6 and so on. This is the tan of when there are n different angles. What is S1? It is the sum of the angles, sum of the tans taken one at a time. S3 is sum of the tans taken three at a time.
Yes,
If
sir.
you see the expressions, you will understand. But the point is like this is not something that is super important for JEE. It is not going to come in. It's not super important, so you can ignore it. The main thing is to learn how to do exercise 20 questions. Do you understand what I'm saying right now? What he's trying to explain?
Yes, sir.
He's trying to show you how to get the formula without memorizing it. For example, tan of A plus B plus C. There are three angles. I will say it is S1 minus S3 by 1 minus S2. If
Yes,
there were four angles, I will say S1 minus S3 by 1 minus S2 plus S4. If there were five angles, I would say S1 minus S3 plus S5, 1 minus S2 plus S4. Do you understand?
yes, sir. Understood. Like Article 126 is also not important.
S1 is tan A plus tan B plus tan C here. S3 is sum of the angles taken three at a time. So all three, there is only one way to take it. You have to do tan A into tan B into tan C. S2 is you take two at a time. So if you take two of them, it will be tan A, tan B. It could also be tan B, tan C. It could also be tan C, tan A. You understand what I'm writing in?
Yes, sir.
There are three options for taking two at a time. There is only one option for taking one at a time. And there are three ways to take one at a time.
Yes.
So if you remember this method, then you don't have to remember the actual formula. You can just figure out S1, S3, 1 minus S2 and get the answer formula for this.
Yes.
Similarly, if I want to find tan of A plus B plus C plus D, right now I know how to find the formula even though I have not done any expansion. I know it will be S1 minus S3 by 1 minus S2 plus S4. S1 will be tan A plus tan B plus tan C plus tan D. S3 will be 3 at a time. There will be 4 terms in that because there are 4 angles. You have to take 3 at a time, right?
Yes, sir.
S2 will be 4C2 6 terms, and S4 will be simply tan A, tan B, tan C, tan D. That is only one term. Do you understand?
Yes, sir. Understood.
But this is not super important. Have you started doing exercise 20 or not so far?
No, I give lot of time.
What?
I give lot of time to the articles, like understanding the formula, something.
You haven't tried any question in exercise 20 so far?
No, sir.
Try question 1, question 2, and question 3 right now.
Okay.
You have 10 minutes. Try for 10 minutes. See what you will do. I'll be back in 5 minutes. Try it. Okay.
Okay.
Are you getting something?
Yes, sir.
Which ones have you done?
Like I'm still trying. Like it is. I do like for the sine 2a and sine 2b. I like sine c plus d formula.
You have to prove that the sum of this is equal to, no, it is subtraction, right?
Yes.
You have to prove that it is 4 cos A cos B cos C. Now, in all the questions of this chapter, you are assuming that it's A, B, C are angles of a triangle. So A plus B plus C is how much?
180.
Pi.
Yes.
So what you should do is group these together by sin C plus sin D formula, right?
Yes, sir.
So you will get what? 2 sine this plus this by 2. So A plus B and cos this minus this by 2. So it will be A minus B, right?
Yes.
So now think about it. What is sine A plus B? A plus B is
Sine a
what?
plus pi minus c.
So sine A plus B is what?
Sine c.
So we can write this as 2 sine C, right?
Yes, sir.
And cos A minus B here, right?
Yes, sir.
What can we write by about this?
Minus 2 sine c cos c.
Now I can take 2 sine C common, right?
Yes, sir.
And I get cos of A minus B minus cos of C, correct?
Yes, sir.
So the thing to do here is to remember that A plus B is pi minus C. So if you take cos of A plus B, what is that? Cos of pi minus C. What is cos of pi minus C?
Minus cos c.
So minus cos C is what? Cos of A plus B, right?
Yes.
So here minus cos C is there. I can write it as 2 sin C and cos of A minus B plus cos of A plus B, right?
Yes.
What is this plus this? Expand it.
Yes, sir. Sine. No, sorry, cos of. Yes, sir. Like cos A and, and cos
It will
B
be
is
cos A cos B, right?
yes, sir. True.
So we are getting 4 sin C cos A cos B.
Yes.
I think we had to prove this was sin C, I think, right?
Yes.
Do you understand what has happened?
Yes. Sir.
So we are grouping the angles together using sin C plus sin D, then using the fact that A plus B is pi minus C, so sin A plus B is sin C and cos A plus B is minus cos C.
Yes, sir. Sir, one question like you can also group sine 2b minus sine 2c. I group it, but I didn't get that.
So if you don't do the correct grouping, if you do sin 2b minus sin 2c, you will get sin of b minus c and cos of b plus c.
Yes.
Cos of b plus c can be written as minus cos a.
Yes. Sir.
It can come from there also. Then you have to write this as 2 sin a cos a. You
Okay,
have
sir.
to
We'll
take
try again.
2 cos a common.
Yes.
If you take 2 cos a common, you will get sin a minus sin b minus c. Right?
Okay. Yes. Sir.
Sin a will be what? Sin b plus c. So it will be sin b plus c minus sin b minus c, which will be 2 cos b sin c.
Oh, yes. Sir. Yes.
So again, you will get the same answer.
Yes. Like it doesn't matter which two groups you are choosing.
As long as you know how to do the next steps properly, take common properly, use this identities properly, it doesn't matter how you group it, it has to come, right?
Yes.
Try question 2 now. Are you getting this?
Yes, sir, I'm not.
You just have to group these two, and then what you get, you have to try to group with this, right?
Yes, sir.
If you group these two, you'll get 2 cos A plus B and cos A minus B, right?
Yes, sir, got it.
Now what?
Now, I write cos 2c in form of uh, a plus b. Like we know
No.
now, a plus b plus c equal to pi. Then I write a plus b equal to pi minus c,
Mm-hmm.
and then twice of a plus b equal to twice of pi minus c, and then apply cos both sides. Then I get cos of 2c equal to cos of twice of a plus b. As I know there is minus 1 on RHS side, so it is better to use like cos 2 theta equal to 2
You
cos
can do
theta.
that. You can also do a different method where you say cos of A plus B is minus 2 cos C. You can write it like this, and cos 2C you can write as plus 2 cos square C minus 1,
Yes,
right?
yes,
And then you can take 2 cos C common here. You'll get cos C minus cos A plus B.
Yes.
A minus B minus 1, and cos C minus cos A minus B can be written as minus cos A plus B minus cos A minus B, right?
Yes.
This minus comes outside, you get minus 2 cos C, and you have cos A plus B plus cos A minus B, which will be 2 cos A cos B. So finally you are getting the answer.
Yes.
Okay. You can do it by what you did also is fine. As long as you do the correct operations and you're getting it, it's fine.
Yes.
Question 3, similar it is. You can try
Yes.
that yourself. Try question 5 now.
Yes, sir. Got it.
Same process, right?
Yes, yes, yes.
Group this, write it as 2 sine C by 2 cos C by 2. This is 2 sine A plus B by 2 cos A minus B by 2. Now what can I do about 2 sine A plus B by 2?
Like same way, a plus b equal to pi minus c, and uh, divide by 2, then you have pi minus 2 minus c by 2. Then apply sine pi by 2 minus c by 2. It is cos c by 2.
This becomes 2 cos C by 2, which can be taken common, and you have cos of A minus B by 2 minus sine of C by 2, right?
Yes,
And again, C by 2 is pi by 2 minus A plus B by 2. So sine of C by 2 will become cos of A plus B by 2.
yes,
So we'll replace that with cos of A plus B by 2. And here you have cos of A minus B by 2 minus this.
the
So
sine
this you
term.
will expand it and you will get basically 2 sine of A by 2 sine of B by 2, right?
Yes,
Here you have 2 cos, so you'll get the answer.
yes.
Question number 8.
Okay.
This time there is no easy way to take anything common here, right?
Yes, sir.
The problem is like we cannot do cos A plus cos B. It's cos square A plus cos square B. There is no formula for that, right?
Yes, sir.
So the only way to start simplifying this is to use the fact that we can write cos 2A as what?
Yes, sir. Because RHS side has every RHS has like cost terms. So
We can use the double angle formulas and say cos 2A is equal to this. And from there we can say 2 cos square A is equal to 1 plus cos 2A. And cos square A is equal to 1 plus cos 2A whole divided by 2, right?
yes, sir.
That at least, what is the benefit of doing this? Instead of a quadratic term, you are getting a simple cos, right?
Yes, sir.
If you get a simple cos for all three terms, you can combine those causes, right?
Yes, sir.
For example, if I write this as 1 plus cos 2A by 2 plus 1 plus cos 2B by 2 plus 1 plus cos 2C by 2, right? What am I getting? I'm getting 3 by 2 plus half cos 2A plus cos 2B plus cos 2C, right?
Yes, sir.
And just now, we have proved an identity for cos 2A plus cos 2B plus cos 2C, which was question 3. I mean, you have not proved it yet, but it is similar, right? If you
It's
solve
question
question 3, what is question 3? Cos 2A plus cos 2B plus cos 2C is equal to 1 minus 4 sin A sin B cos C, right?
no. It is. It should be question two, no.
Question 2, I think. This was minus 1 minus 4 cos A cos B cos C.
Yes, sir.
We just now proved this, right?
Yes, sir.
Where A and B and C are angles of a triangle, we have done this. So now we can use this result here and say half of minus 1 minus 4 cos A cos B cos C, right?
Yes, sir.
So you'll get 3 by 2 minus 1 by 2, which is 1, and 1 minus 2 times sin A sin B sin cos A cos B cos C.
Yes.
So the main idea in this question is how can we convert the square terms? What should I do about square terms? I cannot apply direct formulas. So I'll use double angle formula to write the square term and convert it to a simple cos 2A by 2 and stuff.
Yes, sir.
Similar ideas you can do in question number 7 also, question number 9 also, question number 10 also. You have to try similar things. Now, right now, tell me about question 12. Question 12 is prove that tan A by 2 tan B by 2 plus tan B by 2 tan C by 2 plus tan C by 2 tan A by 2 is equal to 1, right?
Yes, sir.
So it will be annoying to do it. If you try to convert to sine and cos, it will still be quite annoying to do. So you shouldn't try that. What you need to realize is A plus B plus C is pi. So what is A by 2 plus B by 2 plus C by 2?
It's fine.
Pi by 2. And if I group the terms like this, A by 2 plus B by 2 on one side and pi by 2 minus C by 2 here, right?
Yes, sir.
And let's try taking tan here. Tan of A by 2 plus B by 2 is equal to tan of this, right? What is tan of 90 minus C by 2?
Cot C by two.
So it will be 1 by tan C by 2, right?
Yes.
What is the expansion for this?
Tan A by two plus tan B by two by 1 minus tan A by 2 into tan B by
is equal to coming as 1 by tan C by 2, right? Now, as soon as you cross multiply, you will get the proof.
yes, understood.
Can you see how it is coming?
Yes, sir.
You will get tan A by 2 tan C by 2 plus tan B by 2 tan C by 2 is equal to 1 minus tan A by 2 tan B by 2,
Yes,
right?
yes,
So that is the proof for this one. Now, another similar idea in a triangle, you can also prove in a triangle ABC, you can also prove that tan A plus tan B plus tan C is equal to tan A tan B tan C. Now, let's think about this. What I will say is A plus B plus C is equal to pi, right?
yes, sir.
And let's try to find directly tan of A plus B plus C should be equal to tan of pi, and tan of pi is 0, right?
Yes, yes, sir.
And we have learned how to do tan of three angles. We have learned. We know that it is tan of A plus B plus C, three angles will be S1 minus S3 by 1 minus S2, right?
Yes, sir.
Here S1 was what? Sum of all the tans taken one at a time, right?
Yes, sir. Tan A plus tan B plus tan C.
And S3 would be what? Taken three at a time. So there is only one term, right?
Yes, sir. 1 is to the.
S2 will have three different terms, right?
Yes,
So S2 would be like this. So notice that we have tan of A plus B plus C is 0. So that means S1 minus S3 by 1 minus S2 is 0, right?
yes, sir. Now we
That
have
means
S1.
S1 is S3.
Yes, sir.
This is basically what? S1, right?
And that was S2.
Do you understand what is happening?
Yes, sir.
So this gives us another idea for the previous question that we proved. Previous question was what? We showed that this part was equal to 1, right?
Yes, sir.
We did it by one method. Now I can do it by another method. I can say that A by 2 plus B by 2 plus C by 2 is equal to pi by 2, right?
Oh, yes, sir. Now we'll apply tan.
We'll do tan of the three, A by 2 plus B by 2 plus C by 2. And we know tan pi by 2 is infinity, is undefined, right?
Yes, sir.
But this is supposed to be S1 minus S3 by 1 minus S2, right?
Yes, sir.
The only way it can be infinity is if the denominator is 0, right?
Yes, sir.
So that means 1 minus S2 should be 0, right?
Yes, sir.
So
Or
S2 should be 1. What is S2?
S2, yes. Tan A by 2 into tan B.
This is like saying S2 is 1, right?
Yes,
So in a triangle, this identity is true. Also, this identity is true. Tan A plus tan B plus tan C is equal to tan A, tan B, tan C. These are results that are true for any triangle. So you need to recognize these things. Remember that these two results are always true. I mean,
yes,
it will come by practice and by solving more questions. What you need to do is try to solve as many as possible in exercise 20.
okay.
Okay.
By Monday,
Then,
I will complete.
so try to do as much as possible in 20 exercise. That exercise is very important because it helps you get a lot of practice with trigonometric identities and manipulations and all. It should not be that later you are scared of some trigonometric expression. The point of all of this practice is that you are not scared of such things later. It's not like this question will come in the exam, but similar things might happen. And if you're not comfortable with trigonometry, then you'll not be able to do questions. Okay.
Okay.
So exercise 20 is the homework. We'll discuss the doubts and problems on Monday's class. Okay.
Okay, sir.
Fine. That's all for now then. I'll see you next class.
Thank you, sir.